Do we have a middle name, Dan?
Probably.
All right. And it's going great up here. Warren, I don't know what exactly you did, but it was too much. I will say that.
I need to lose some weight.
Please welcome Dan. All right, it's fixed. Let's go.
All right. Warren, please respect this restraining order going forward. All right, hi. That took a minute, and I really apologize. My name is Dan Vail, and my talk is called I Am Dumb, and So Can You. So, first of all, who the hell am I? That's a good question, but don't ask questions you don't want answered. Like Aaron said, I play an antagonist online, and if you've ever seen this face, I apologize. This means nothing to me, Dan. I know, and I apologize. Some creds. Number one, I'm a C++ engineer, which makes me better than most of the people here. I'm also the best violinist you've ever met, and I'm currently on stage, and that's called appeal to authority. So what's my deal as far as this talk goes? I want all of you to embrace being dumb. It is a 50-50 chance whether or not you are smarter than average or dumber than average. Some of you might be right on top of the bell curve. Congratulations. You're the side of the coin we don't care about. So just pretend you're on the dumber half. Once you do that, you're going to be liberated in a way that I cannot describe to you until you try it for yourself. When you stop trying to be smart and you just play around like you're a fifth grader or a kindergartner or some other young child in some mud, you play around, you pretend, you learn a whole lot more than trying to massage your ego the entire time. I forgot to do the animation on that one, my apologies. So, we've gone over liberate yourself. You can build anything you want for fun and profit once you're done. You're allowed to just build things for purely your own pleasure. We're going to do an example of that in a second here. You're probably not going to make money off of it. I apologize, but that's the way it goes sometimes. What are we going to use my dumb to build? Whatever you want. And we're going to try a programming language because there are only a few of them out there, and we kind of need a lot more of them. JavaScript hogs a ton of memory, so let's make ours hog even more memory than that. We'll call it hoglang as a result. We'll focus not only on the developer experience, but we're also going to focus on the developer experience derived from developer torture. Kind of looks like that. So why would you make your own programming language? Learn about compilers, learn about interpreters. The more you know about how your code will actually run on the hardware, the better programmer you can be. And that means you're going to understand your own language better. It can be abstracted by many different things, V8, Chrome browser, I don't know, whatever else web technologies are out there, so just pretend, like I said, other things that were smart. And I've decided you're going to have fun learning how to make a programming language. Can I use LLMs to help me? Yes, but I have two caveats that are going to be a little bit painful, and I apologize, but it'll be better for it. No copy-paste or anything like that. So no cursor tab complete, no agentic LLMs trying to help you out, and you must also rename every variable that the LLM creates to another meaningful name. This means that you're going to understand the code that's being written. You're going to be able to know what values you're getting from different functions or different structures of data that you're getting all around. You'll have a better idea of what you're writing. But you can still use it to help you. So let's get started. We're just going to do very basics to start. So if we want to hog memory, we're just going to make it a gamble. We're going to gamble somewhere between 2 and 5 times what the user wants us to actually give them, but we're only going to give them access to what they ask for so they can't game the system. Like I said, I'm a C++ engineer. I don't write JavaScript or TypeScript. I think this is right, but I don't know. This is kind of what it looks like. We have a memory tracker with symbols. That's going to hold all of the different variables that we have in memory. We have allocations, which we're going to use and just roll a random number, see how high it goes, and that's going to be the amount of memory that we get for any given type that we allocate. Now time for the syntax. And this is the part that I personally find the most fun, because you can just decide whatever you want is valid syntax. You aren't constrained to C style or functional or anything. We hog-tie pigs here for our programming language. So as a result, our first line is going to be hog-tie some value to some variable. And this is what a parsing function for that would look like. Again, it's very dumb. We are not trying to be smart. We're just trying to have fun, see what it looks like. We try to see, does the line start with hog-tie? If it does, congratulations, we can now allocate some memory, put the value in there, move on with our lives. We're all happy. But we also have print functions. We have to actually write something to standard out if we want to make a hello world. There are two different kind of print functions in our language. There's oink, which is just printing to standard out, and there's squeal, which does the exact same thing, but it capitalizes everything. This is effectively what it would look like if you were to use those two. Please be quiet, Bisco. And again, we're just doing a very simple, hey, uppercase the thing in this function here, and if we find the first keyword to be oink, we're just going to print standard out. If we find it to be squeal, we're going to uppercase and print it standard out. What about non-strings, though? Because if I pass in something like 5 plus 7, I don't expect it to print the actual 5 plus 7. I would expect it to evaluate that expression and print out 12. So what else needs to be checked here? We need to see if what inside of it is actually an expression that we need to run and evaluate that expression. For right now, we're only going to parse one argument. We're not going to try to do formatting strings. We're not going to try to do anything really special. It is a very simple, here's an expression, add x plus y. We're also going to need to have multiple files because we're not Python developers. We don't like sticking everything in one giant file. And so we're going to need modules. And as a result, we introduce wrangle pig. So each pig that you wrangle is a different module in your system. You're going to need to scan directories however you decide. You're going to need to scan through the files to find everything that's being declared and then actually pull that into the symbol tree. This is pseudocode for that. I left the implementation up for the reader because I am lazy and didn't feel like doing it. We have print statements, we have imports, we have our assignments. As dumb as this language is, it is technically a real language, and we started on this process learning how to write parsers and learning that there aren't always going to be straightforward things. So with oink, we're going to have something we want to print, but we might have an expression that we first need to evaluate. It's simple, but it's the start of understanding how compilers and interpreters look at code and how they go from something we understand to black magic that appears inside of my computer and makes me scared at times. In this case, we have ID equals expression, left num, operand, right num. It's the beginning of a grammar. Grammars are scary. There are many different types of them. I don't recommend trying to look at this slide too long because it will give you nightmares. We're going to do one more pig-themed feature before we end. Pigs can also be used to search for truffles, and so as a result, we're going to do truffle sort. But because we're also focused on developer torture as our developer experience, we're just gonna give up halfway through if we feel like it. Flip a coin, and if the element isn't the right element, maybe we give up, maybe we don't. Who knows? It's an indeterministic system. This is something that should hopefully be implemented correctly that would effectively do exactly that. Just search through a collection, see if we found the thing, maybe give up along the way, who knows? Things to consider for the future. Keep adding features that you enjoy. This is a toy language. There are many other toy languages out there, such as Dreambird, if you've heard of that one. But the core idea is just, if it makes you smile, if it makes you laugh, you're going to have a much better time actually implementing the thing than trying to implement something for some sort of clout or credibility or profit. At the end of the day, if you work on something, even if it's dumb, you're going to become a better developer for it. Also, keep going back to improve. I have had many different projects over the years that I've looked at, I've started, I've written, I abandoned, like a lot of us have, and then went back to later and said, okay, I'm a better developer now, and I want to make this system better. And then you start tearing parts out, you start working on them, making them better, and by the end, you're like, okay, this is actually a much better system than I originally started with. But it's effectively the same product. So you get to see how you've improved over time when you go back and improve these things. Get more ambitious about them too. Whenever you come across something and you're not sure if you can do it, give it a shot, because a little bit of persistence and a little bit of willingness to kind of look like a fool will get you a lot further than saying, I'm not smart enough to do this, or I don't have the capabilities, or I don't have the skills. Make fewer projects is probably my favorite one. I worked on maybe 2 projects last year outside of work, and I invested a lot of time into them. And you do get to the point where it's not as exciting because it's not this new fun project. You don't have the cool ideas that are actually implemented. You have to do the very grungy, dirty work. But if you stick to them, and you stick to just a couple, you're far more likely to see yourself through the parts that suck and get to the part where you actually have something you can show off. Main takeaways: being dumb means letting yourself explore and have fun. Joy, in my opinion, is one of the only reasons to build something outside of your work. Unless it's a convenience thing or it's something that actively helps you, joy should be the main driver of what you decide to build. Don't overcomplicate it. Everything needs to begin dumb. No programming language has ever started by over-architecting it and saying, okay, well, we can't start yet because first, before we need to write the parser, we need to write a linker, we need to write a tokenizer, a lexer. Just start writing it. If you're not having fun, take a break. I would encourage you, don't make that break permanent. Go back to it, try it again. If you've tried this multiple times, maybe it is time to abandon the project. I'm not saying you have to be beholden to this thing forever. And never stop having fun, and never stop learning. I love you very much. And by the way, I've been working on Hogling in my free time. It is in a very bad state because I've gotten very busy. But if you want to see me start to work on it as soon as I have a secret project wrapped up, then you can go to that GitHub link and check it out. Thank you very much.
All right. I'm ready to be mean. Are you ready? That was slightly above average.
Thank you.
Hey, I did it. Are you proud of me?
Oh my God, I am.
Thank you. Okay, so one question I have for you is, I think as developers, many developers suffer from what we'd call imposter syndrome. Mm-hmm. And you come up here and you're like, I'm dumb and so can you. I'm a C++ engineer and I wrote my own language. So what is what is your charge to the people who feel like, yeah, I am dumb. That's the whole problem. That's why I feel insecure. So like, what do you say to those people, and how can we get over that?
Well, you can either say that you're dumb, and in reality, you might be very smart, or you can just say, I'm dumb, and effectively own up to that. You can make mistakes, you can say, my bad, and then you can try to get better. You're never going to be at a point where you're perfect, where you have every answer to every question. And I feel that some people, myself included, have had points where if they can't answer every single question at the drop of a hat, they don't feel like they can step away from that imposter syndrome.
And one of your points up there was be more ambitious. How do you, what are the failures you see in developers when you're like, man, they're not taking enough risks, they're not being ambitious enough, they're thinking too small? Why did you put that one on there?
Because I think a lot of times people look at very complicated systems and they say, I can never do that. I don't understand how to write a compiler. I don't understand how to write some very advanced web framework that I'm not familiar with. Is React a web framework?
React is a library? React is a...
React is an operating system.
Okay.
It's just a matter of saying, I'm going to try this anyway, and I might fail, and that's okay. We have far too many people in and out of tech that see failure as this detrimental thing instead of as a time when you could say, okay, but what did I learn here, and how can I move that forward into my next thing?
Y'all give it up for nice guy Dan.